So let's take a deeper dive into C, C++ string, but the focus is on C, right? So as we stated earlier, so C is a collection of characters. So C++, but in reality, your C string, right? C string is an array of characters, array of chars. So what you're looking at here is a C literal, right? C string literal, which looks exactly the same as your C++ counterpart. But what is different between the two is, like I said, C++ string is a class. So this is a class, right? But this one is a array, okay? This is an array. So sometimes the array, right? So the way that you would express this, since this is a array of chars, is char start. But we'll get into the array and what this extras really means later on. Doesn't really matter. Now, if you have a C string with edu in it, what you actually have is 3 characters in it, right? E, D, and these are single, right? Apostrophe, right? Because these are characters, not double quotes. Edu. And the very last one is /E0. This /E0 is the same as null. So every single C string, so this is a string literal, right? Every single C string literal ends with a null terminator. So this is very important. Let me use a different color. This is a very important aspect because what we're looking at here is for a C string, right, to take up memory space at runtime. The amount of memory required is the length of the string plus 1, right? Because of the null at the end. This is very, very important. C++ doesn't have it. C++ string with a class has all of the methods needed by a string manipulation. So it's very self-contained. And the drawback is, of course, the size of your right C++ string. By default, the size of C++ string, right, if you do it this way, is 24, right, on the machines. But this one is only 4 bytes. This edu, this one is 4 bytes. Okay, all right, let's take a look deeper dive into some of the methods that we frequently see in C string and how they're used. Now, the reason why we're talking about all of this, right, is just because in C++, you're going to see C string too, okay? And if you don't know how to use it, sometimes you may get confused. So you need to know this. Here's a couple of examples. So we're listing out 2 methods that are, these are not methods, I'm sorry, these are functions that are available to C string. And these methods, or these functions are in C standard library. So in order to use these methods, the first one is strcpy, which stands for string copy. The second one is a strcat, which stands for string concatenations. So copy and concatenation, 2 different things, right? Concatenation is putting 2 strings together. String copy means you have to have some sort of existing buffer and copy the new string into it, right? So these are the differences. Now, in order to use strcat, string, strcpy, strlength, right? The size of the string, these things, you have to include, you have to do a pound include C string, okay? Now, what is this? C string is for C language string, right? So we just talked about. You might have seen another library called string.h. Now, every time you see a .h, this is C, okay? C-lib, C libraries. So string.h is kind of confusing, right? Because in C++ we use string as well. So this is the reason why later on in recent years, right, or decades rather, we came up with a C string, right, library. So these are equivalent, okay? C string is literally a wrapper, a C++ wrapper for string.h. So you will see C string, you will see this. Now, if you want to use C++ string, right, in that case, you would pound include what? And you probably have used this already in your homework, string, okay? And there's no .h, right? If there is no .h, use C++. And there is a .h right here, or use of C string to represent C. This is the C standard libraries. Now, let's take a look at what's going on with this strcpy and strcat businesses If you were to go through the example here, initially we have a buffer of 80, right? This is 80 bytes. This is 80 bytes, okay, in memory. So this is a pretty long, right, list of array, right, with 80 of them, right, starting with index 0 all the way through index 79, right? At some point, it ends right there. Now we're copying Pasadena. Now Pasadena has 8 characters in them, right? So this is going to take up the very first. For brevity, let me just eliminate the use of apostrophe here. Pasadena, right? So on and so forth. Now, this stir copy means take the existing str, which is the buffer, right? This is also another word for this is array, right? Or buffer, right? So so computer scientists is that we use different terms for different things, but in this case, buffer is the same as array. So if we're gonna copy Pasadena, character-wise, right, into this buffer of 80, first of all, this will go through, well, because the Pasadena, right, your destination, your source buffer only has 8 characters, but your destination buffer has 80, right? So there's sufficient spaces in there. So after the copy, you're gonna get 72 more empty spaces out there. Okay, so that's the first thing. Concatenation literally takes what is in the source into a destination. So your source is str, which already has Pasadena in it, right? But because this is a C string, what happens is in Pasadena, at the end of Pasadena, there is a /0, right? So this is the null character, okay? Because it's null terminated. Now, what's going to happen is this CT, right? C, this letter C, right? Let me use the different colors here. This letter C is going to concatenate into this null characters, right? So this is a pretty expensive operation because your method, your function strcat doesn't know where this previous string terminated at, right? So it basically has to, like, as part of the strcat operation, it's going to have to look into every single one of this, looping through it, right? And the 9th character is going to land on this null and says, oh, I just found, right, the glue, right, where these the next or the source needs to concatenate into. So this is going to take the very first character C, right? C is going to be occupying this space, and then CT, right, would then be concatenated that way. So strcat looks for basically the ending, right, the null terminator of the prior string and concatenating it. So by extension, your college is going to concatenate right into your null terminator at the end of the city, right? The word city. At the end, what you're going to have is a string called Pasadena City College with no spaces. Okay, so this is how this is used. Let's kind of move on. Next, there is a pretty dangerous thing that happens here, and that is, let me preface this dangerous spot right there. That is, this entire string is not initialized. Now, usually I ask the students what's the big deal, right, in this? It is a big deal. If this is not initialized, this means that, in this buffer of 80, right, 80, you can have any characters, any data left unattended from before, okay? So this could have a value of, let's say, 1. This could have a value of a character, right? So these are undefined, okay? You're gonna have undefined stuff in it. So like, how does it, your strt copy know, right, where to copy this Pasadena into, where to begin? Well, fortunately, strt copy takes Pasadena, right, P, and dump it into the very first character. That's what happens when you have this copying operation, right? Since this is not concatenations, it'll basically go to the beginning, right, the very first location or the elements of your str, which is the zeros, right, the index location, and copy Pasadena into it. So there's no issue here, right? Even if you don't initialize it. But what ended up happening is, for the initial portion, right, at the end towards index 78, 79 ish, yeah, they're not necessarily 0, okay? So instead of being 0, they could have value in it. So it's a very confusing landscape here. But this is the result of not initializing a variable prior to using it. So let's move on to the very next one. So why do we have to use stir copy before strcat? Like I said, be wary, right, of strcat in stir copy, right? So looking at this example right here, where you have a strcop, actually a string buffer here, and you're trying to concatenate this into that, right? So what would happen is your very first null terminator, right, is going to be identified. So in this case, if strt hasn't been used before, and you're hoping, right, maybe the very first character is a null, right, and typically it is, right, but it is not necessarily the case. And CITY, right, would then be copied into them, right? And this is how strcat works, right? Taking this into, right? So this is the source, and this is the destination, right? Source into the destination, looking for a null terminator. Now, what if in this case, your very first, since str, right? This is str, this is str. This is one version, this is not a version. Since you created this str buffer with 80 bytes in it, what if the next, stir because it's not initialized, it has value in it. So 1, 2, maybe A and B at some point, there's a 0 at the end. What will happen is if you do a strcat that way, then your CD will then be writing into this location, right? And this location is where the issue is, right? Because you don't have, this is CITY, right? So starting at this location. This is going to give you some garbage, right? Obviously, this is unintended, right? You don't want any of these things in there. So it's best to initialize them. So I'll give you another example of what would be the best practices moving forward. And one thing to do is to initialize it, right? Uniformly initialize it with a number in it, for example. In this case, you can have a default null in it. So you want to nullify the entire string uniformly across the 80 bytes that you have here. So that's one str C string example. You will come across multiple functions out there that are available for C string. And so some of the examples include, but not limited to, converting a string to an integer. So you might have seen S2I as well. So A2I is available in some platform-dependent C libraries. So this may not be available on your own. So I wouldn't use this. A lot of times instead, you'll see S2I. So make sure you go to c++.com, right, this website, and look for the corresponding, and this should be in your C string, right, header file. There is not a .h right here. So in order to include it, it will be string.h or C string, okay? This is how you use C. Copying a set number of digits into it. So n stands for the number of bytes, right? So if you would just want to copy, 5 bytes from this source into the destination, you can specify n. So there's actually another parameter that specify n in this function. Size of the C string. So this returns the length of a string, okay? Not, okay, including terminator, no. Okay, so if your string is C++, it'll return 3, right? Because C++ is 3, size is 3, length is 3, not including null terminator. So you can guarantee this str only returns the number of characters. strchr, this is a find or search mechanism that returns the first occurrences of a byte in it. So strchr looks for a particular character that exists in your C string. There might be multiple occurrences, but this one returns the very first, right? So it starts at index 0 and start looking for the possible location of this CHR or chart and returns the very first occurrence or the index, okay? This is the array index in that entire string. So if your first occurrence is 5 for this character in this string, it returns 5, okay? All right. So that's that. Let's move on to the next one. This is some of the other examples. As we can see here, the first example, string copy this PCC into 80. Sometimes this is pretty dangerous, because at runtime, you don't know how much is left, right, in the STR. So by virtue of, or how much is being allocated for STR. So when you copy something, right, into a buffer at runtime, because anything can happen at runtime, if you're not careful and copy your source, which exceeds the buffer size, you're going to get runtime error. So very dangerous thing to do. So this is the reason why we don't typically hardcode this 80 in there. We would use, this is static allocation. Static allocation basically means that you're hardcoding a value into this buffer, and you statically instantiate it, right, on a stack. This is stack memory. Okay, and the size of STR, remember STR is a char, right? This is a C string. So what's going to happen is the size of STR, when you copy PCC into it, it's still going to give you 80, right? Because there's 80 bytes, right, in this STR, regardless whether the STR in this case CL is only PCC, right? So when you see out this, you get PCC, but when you print out the size of this thing, this gives you a buffer of it. Okay, so that said, this is another way of initializing your string, C string. You can do it this way without, if you don't push anything in it, by default, this is all null. Okay, this ensures that you have uniform initialization of your string buffer with no value in it. Now, when you stircat this, then this is safe because P, right, goes into the very first null, which is at index 0, right? So this will give out PCC as well. And when you slice off this should still give you 80, right? Not 3, right? So this is the difference, between not really the difference, but the contrast, right, behind the two sort of methods that you use here. Okay. All right. So let's move on to the next one. Let me clear this. This is another an example, right? If you would like to print out the individual characters by array indexing, you can, since both C string, you can treat them as an array of characters, and they are, right? You can use the bracket notation. This is the standard array notation to print out the very first character, second character, third, fourth, and so on and so forth. And of course, you can use size of STR. If this STR is not a C string, but a C++ string, like in that case, then your STR is going to, right, your size of is going to return 24. This 24 stands for 24 bytes. So we talked about this before. But the size of, right, obviously STR in a C string will be a lot shorter, smaller in this case, in the examples given. All right, so this completes our kind of a deeper dive into C string. So we're going to talk about C++ string in the following video.